All right, I'll just get started even if no one is here. Okay, so this cell is odd. So it's 1, 3, 5, 7, or 9. And along the German whisper, the digits differ by 5 at least. If an S cell is found on the line, both digits follow the rules. Oh, that's interesting. Okay, so two things to know about a German whisper are, one, that it oscillates in parity usually. So if we're just talking about the digits 1 to 9, then the digit 1 here would have to go next to a 6 or higher. Now, the weird thing about when you're looking at 0 to 9 and S cells is that 5 can go on the line, because normally in a regular puzzle with 1 to 9, if you put a 5 on the line, you usually can't put a 10 on the other end, which you can't in this puzzle, but we can put a 0 in this puzzle, which is a little bit of a hiccup, but not too much of a hiccup, because in this box, we need to put a 5 somewhere. It has to be somewhere. So I think the only places for 5 are in one of these two cells. 5 in an S cell puzzle functions a little bit like 4 or 6 does in a regular German Whisperers puzzle. So if you put a 4 on a German Whisperers line in a normal puzzle, and in fact in this puzzle as well, then on both ends you'd have to have a 9, because you can't have a 10 or higher, and there's nothing that's -1. You can't put -1. Even in this puzzle, you can't put -1. So a 4 will always be flanked by double 9. So in this case, on this line, it's fine to put a 4 in the middle of this line. But here, if I put a 4 there, then I have to put double 9 along here, and that's not going to work. So the other one that is a little bit weird here is 5, which is now sort of replacement for 6, because 6 can go with 1, obviously, or 0. So now 5 is sort of the new 5 is the new 6. We're bullying 5 now. 5 is getting ganged up by 0s now instead of 6 by 1s. So one of these two has to be 5, because if I put a 5 here, it's going to be 0 or 0. Oh wait, I guess I could put a 5 here and 0 and 0. That works. Crackly, okay. I figured out there's a 5 in one of these 3 cells. Yeah, it's only a problem with, you add phobia to it. Yeah, start junior. Anyways, so if this is 0, it's kind of interesting because 4 cannot go next to 0. So aside from 5, it's... Okay, we need to figure out this 5 thing because it's bothering me now. Is there... Oh, wait a second. There's something easier, I think. So I first noticed this box is full of green lines, but I didn't notice, right away at least, that this column is also full of green lines. Don't know why I didn't notice that. I guess these sort of deceive you a little bit. But so we can't put a 5 there. Could put a 5 there, maybe. That would put a 5 here. So you can't put a 5 here. So there's a few spots still. 5 spots for 5. Did already see the solve. All right, see you later, Stark. Right. Yeah, I have heard Simon say it, but I haven't, I just didn't internalize it myself for some reason. Okay. So there's something to do with this column and this box that I can't quite figure out. There's not a lot of information in this puzzle. That's why it's called the paradox, I think. So let me think here. If an S cell is found on the line, both digits follow the rules. So let's think about the S cell in box 5. Because I just want to think about what an S cell on a line means. I mean, an S cell on a line is slightly more restricted than just some regular old cell on a line because you can't, maybe the word is like de-restrict it as much. If you put just a regular 0 or 1 into a cell, then the edges are not very restricted. I guess you could put 0 and 1 in the cell though, but maybe the other way is better. If you put a 9 into just some cell, it doesn't restrict these basically at all, except for that they have to be lower than, well, 4 or lower. But 8 or 9 is a little bit more restricted. Then you can't put a 4 here, so an S cell would need to never have a 4 next to it? Is that the only thing I get? Really? So maybe we should think about the 4 and 6 in this box as well. Because that's probably important as well. 4 and 6 can't go here. Oh, this is probably it. So the 4, whenever you're trying to put a 4 and a 6 on a German whispers line, you always want to put it on like something like this, where the two cells don't see each other, or something like this, where it's the end, so that only one cell is along the line. But here we can't do that. 6 is less restricted, as we talked about. 6 is no longer being bullied by 1. It can relieve itself with 0. So 6 is a little bit less interesting, but I think 4 is interesting. So 4 can never go, so 4 can't go there. 4 can't go there, 4 can't go there, 4 can't go there, 4 can't go there. 4 can't go here either. Sort of the same thing as 5. Oh, the exact same thing as 5. So 4 is in one of these two cells. So one of these pairs, this one or this one, has to be double 9. And 4 is a little bit even more restricted than 5 because 4 can't go in this cell. So well, that means this is never a 9. Little deduction there. But it also means, how does this line up with this? If this was a 9, and this was low, and this was high, and this was low, and this was high, then it seems like I feel like you can't do 4 and 5 in these two cells, or the other way around, because if you tried to do that, then I think you run into a big problem. Because this cell will be from 1, 2, 3, 4. This cell, even if it could be from 0. It could be from 0. Yeah, but 1, 2, 3, 4 is 0. But this cell still has the restriction that it has to be at least a 5, which means that this cell has to be at least, even if this was 5 or 9, this would still have to be less than 4. It can never be 5. It can't, yeah, you can't get high enough here. So I could see this in my head, but I'm not sure how. Hello, hello Zetamath, and I'm doing advising all day, but I had to stop by and say hi. Hello Zetamath, and hello Androsakis. Nice to see you in chat. Don't worry about. Have you resisted high-low coloring? I don't have high-low coloring yet, I don't think, but I might get it now because I know that this is a 5. Because I can't put 4 and 5 together. I guess you can sort of high-low color. It's weird because... No, you can high-low color because it sort of just expands the list of things, but doesn't change the effect of what it is. I might be at a disadvantage solving this because I have never solved, at least all the way through, I believe it's called Kodama, is your puzzle Zetamath? I don't think I've ever finished a solve of that. I've done the other one. I can't remember if Kodama is the one with German whispers or if Kodama is the one with... Okay, I've solved the other one, Archa. I think I've solved that one. And I started Kodama, but I didn't finish it. Yes, I realize now that there is high-low coloring, so I can do that. And it's going to be a little bit weird because 5 is now high, I guess. So we can label all these as... Wait, I thought those were not going to be the same parity. Oh no, those are... Right, these are going to be the same parity. That's the point. These are going to be the same parity, so they couldn't be 9 and 0, right? That makes sense. So we can color all of these cells, trying not to misclick so I don't have to redo this, as being high or 5 or higher, I guess is the definition. And then these cells are 4 or lower. And one of these is a 9 and one of these is, or one of these is a 9. Or, sorry, either these are both 9 or these are both 9, depending upon where the 4 goes in this box. Yeah, I never solved Kodama, but I'm guessing that I looked at it long enough to not realize the that you could still do high-low parity in the puzzle, so I just never realized what was intended there. So there is still... Wait. There is... How many low and high numbers are there? I'm trying to see if we can get a figure on this, whether this is high or low. So there are definitely 5 digits which are low and 5 digits which are high. But the problem with both of these as digits, is that we haven't identified where the S cells are, because an S cell can have 2 digits in it. And that also gives me a problem with this digit. Oh, no, it doesn't. Does it? So if I put 1 and 2 in here, okay, no, this cell still needs to be, right, okay, we have all the high digits in this column. This is the easier way to think about it. We have all the high digits in this column, so this must be low, because there are 5 high digits in this column. But these 4 cells don't contain 4 digits. They have 5 digits in them, and 2 of those digits are going to go in one cell. Now I've noticed that this cell can't be a 4, so there's a 4 in one of these 2 cells. I'm just going to mark that very messily across several boxes. But oh, this being low means this is high. So we've basically finished the puzzle now, I guess, because we've colored it in. But we also need to have, oh, one of these cells has 2 digits in it, because there's only 4 cells here, and there's 5 high digits in box 5. This is from 1, 2, 3, but 1, 2, 3 could also be here. This is the problem with S cells, is you can't notate them very well. This can't be 9 because we already figured that out. Can still be 7 because 7 could go next to, oh wait. No, the fact that 5 is in here does actually tell us that this is 0, because nothing else can go next to 5 on the 1. That's actually a fact. Same thing with 4. If I put 4 there, then these have to be 9. They can't be S cells with 9 and 8 because it says that both digits follow the rule that they have to be at least 5 different. I guess it should probably say all digits follow the rule, because you could have 2 S cells next to each other and then both digits follow the rule both times, I guess, is the idea, but I don't know. It's pretty clear. It's pretty clear what you mean by that. One of these cells has an 8 in it. Oh, that, I don't know why. I connected this cell and this cell in my head, and I was thinking, oh, that's interesting because the 4 is next to the 8 on the line, but that's only true of this cell. Where does 9 go in this box if this is the arrangement? 9 goes right there, if that's the arrangement. Which means that wherever the 3 is in this box, oh no, the 3 could still go there if that was the case. If this was a 9, I was thinking that the 3 would have to go here, because 3 has to be flanked by 8 and 9. Still it has to be flanked by 8 and 9. Wait, that's actually interesting. 3 has to be flanked by 8 and 9. Unless you could do the same thing with 4, because you could still do this, or you could still do this with 3, of course. That's not against the rules. But I'm thinking that because 4 is sort of taking that opportunity, does that mean that 3 in the box must be flanked by 8 and 9? Or could you have a situation like this, where these are both 8 and these are both 9? That seems feasible to me. Okay, so sorry, I'm just catching up on the chat. I have a second yeah, you can give hints for sure. I have a second monitor, which I would love to put Twitch chat on, but for some reason, every, I don't know, 2 weeks or so, my second monitor decides that it won't turn on. And just so happened today, it decided not to turn on for some reason, which is great. I should... did I say Twitch chat? I meant the chat. T-chat, the chat. Yes, chat is encouraged to give hints if I am stuck. And if I put in wrong digits like that for. I always do that and think to myself, there's no way this doesn't lead to... Oh, pencil mark across boxes? It usually doesn't lead to a catastrophe for me, but we'll see. Simu stream? What does that mean? Oh, on Twitch and YouTube, you mean? Both at the same time? Hi, hi Cogito or Sam. we are trying a S-cell puzzle, and I am not doing it very well. Okay, so, well, I know that 9 is either here or here, because if 9 is in these cells, then 9 is here. So it's either here or here, obviously. And in this column, 9 is in one of these two places. And in this row, 9 is in one of these two places. Yes, this is the direction madness lies, I believe. Yeah, I don't know. Does that, Xeno, does that work with, like, merging the chat somehow? I don't know, like, would I be able to see both chats? Also, is it still crackly? Or has it evened out or something? Yeah, with a smaller audience, probably works better. Well, now I'm sort of thinking that maybe the digit 3 is interesting because these digits... Wait, no, that's not true. That's not actually true. I was going to say these digits can't be 3 because this can't be 9, but of course this can be 8. These can't be 4. Maybe I should think about the S cell in this box. So one of these, oh, where are we going to put the 6? That's the question. Where are we going to put, oh my god. Wake up. Where are we going to put the 6? Where are we going to put it? Well, just like the 4, the 6 needs to be surrounded by 2 very small digits, the other way around for 4, but I believe the only place to put 6 is right here, because every other place where we could put a 6 where it wouldn't need its new friend, the 0, we would need to put it either in one of these two cells, as we've discussed with the 5 and 4, or in this cell, and this cell cannot be 6. So this cell must be a 6, and it must be flanked by 0 and 1. And this cell must be a 1. This cell actually... Oh, this is so annoying. This cell is a 6. It is a 6. But it could easily be a 7 as well, because it's an S cell. Maybe it has to be, because... Okay, so there's definitely a 6 in here, and I was going to say, oh, that place is 9 here, but no, it doesn't. Not quite. This has 2, 3, and 4 in it. So that means these two digits are actually pretty hard to fill. No, I connected this again. I literally connected this again. Oh, in column 5, you're right. I was thinking about the box, Andrew. You're right. It must be in... I wish I could mark them as not S cells as well. So if you turn it down, the compression would automatically compensate. Oh, I just realized that there's only 2 places for 9 in this box and this box, because if I put the 4 here, I just accidentally pencil marked something. No, I didn't. If I put the 4 here, then the 9 is here, right? So if this was a 4, this would have to be a 9. That would clash in the box. So this would have to be a 4, and this would have to be a 9. But the other way around is identical. If this is a 4, then this is a 9. So this cannot be a 9. So this can not be a 4. So this must be a 4, and this must be a 9. So in these 2 boxes, these are where the 9 go. Very weird. I just placed a 4 by accident. neither of those is an issue with this, no. Neither of those would be an issue. Okay, so let's think about the 3 again. Because the 3 seems like it actually is really constrained. Like if I put the 3 here, even if there's a 2 in this cell, well, there can't actually be a 2 in that cell, but then this would need to be an 8, 9, and this would need to be a 6, 7. I'm just thinking, if I put the 3 here, obviously these have to be double 8. And if I put the 3 here, these also have to be double 8. So no matter where I put the 3, there's always an 8 in one of these 3 cells. And I guess we always get an 8 in one of these 2 cells. No, we don't. No, we don't. Because this could be a 3 and then 9 and 8. I feel like there's something I'm not understanding. I mean, maybe... Okay, so the digit 7 definitely cannot go here because it can't be next to a 3 or a 4. So this one has to be 8 or 9. And it's not an S cell. Yeah, it can't be an S cell. No, it can be an S cell. Yeah, it can be an S cell. Oh no, it can't be an S cell. What am I saying? It can't be an S cell. Because if it's an S cell, it's both 8 and 9. And if it's both 8 and 9, then the 9 in the box is not used for the 4. Well, not the 9 in the box, but like, if this is an 8 and 9 S cell, I need the 9, if the 9 goes here, this is a 4. But if this is an S cell and it has a 9 in it, this is still a 4, but it can't go next to an 8. That's probably the only way I can explain that, but there's so many variables going on here, it's hard to articulate. So this is 8 or 9. I feel like I have spent a long time on this one box, but I have also been spending a long time dealing with Crackle. And let's not go back to the Crackle, but I want to ask, is there more Crackle? But I will refrain from asking if there is more Crackle. Is there always an 8 in one of these 2 cells? Yes, there is. Because there's a 3 in one of these 3 cells, and we need to use the 9 for the 4. Yeah, I could use letters for non-SL, you're right. Thank you for the offer. To help with the audio, I mean. I don't want to turn on letter tool unless I have to, because letter tool makes it so that Control Z and like Control A and Control Y, it's all like messed up and stuff. It's a little bit annoying for me. Multicoloring, yeah, I could multicolor. Yeah, I could multicolor. Let's multicolor, I guess. No, not those cells. These cells. Wait a second. Yeah, okay. Yeah, so maybe I should have been coloring that, because this is an S. Okay, scratch out like 20 minutes of that if I had just colored the non-S cells. Pretty much. Alright, so this is an S cell, so what's in it? There's definitely a 6, and there's either a 7 or a 9. If there's a 9, then this is 8, 7, which means that this has to be a 2. There's a 9 here, this is obviously a 4, so this is a 3, so this is an 8. So this is 8, 9 for sure, and it's not an S cell. So where does 6 go in the column? That's the next question that we should have asked a while ago. That's a 2. Wait, hold on. Get rid of this pencil mark. 6 definitely can't go in either of those 2 cells. And 6 can't go in here already. We already have that. So this is a 6. Like, okay, this puzzle's not too bad if you pay attention, you know? Okay, so this is 5 or... no, I'm doing the other way around. This is just a high digit. It doesn't have to be 5 or 6 just because this is a 0. Don't do that. Okay, so this is a 6. So these are 7, 8, 9. So if I have a 7 in one of these 2 cells, then one of these 2 cells will have to be a 6. Or one of these 2 cells would have to be a 2. And if one of these 2 cells has to be a 2, I'm just proving the same thing over and over again, because this has to be a 3, then this has to be 8, 9. Okay, these are from 2, 3, 4, which gives a 2, 3, 4 triple in this column, meaning that this can't be an S cell. And these can't be S cells, because if they were, then they wouldn't be able to be with a 6. If you had 1, 2 here, then the 2 would clash with the 6, because it would be too low, or too high, too low. 1, 2, 3, 4, 5. So there's a 0 at the top of this column, and it could be with something else. It could be with something else. So there's definitely a 0 up here, and this digit is definitely high. I guess we could just see that from the pencil marks. These are low, so it can't be 0. It's definitely a 1 in here. 1, 2, 3, 4. This one's not a 4. So this one can't be 1, and it can't be 4, so it's 2 or 3. This one can't be 4 either. So this is 4. When you overthink a puzzle. When you severely overthink a puzzle. Why was that pencil mark with 3? I think I accidentally did that. So these are not 9s. And this is not a 9. So that is a 6, 7, which means that this is an 8. Is that true? Why did I say 8 can't go here? If this was a 7, and this was an 8, why can't this be 2 and 3? Well, this can't be an SL for sure. I'm gonna think on that one. I don't know. 5s in boxes 2 and 8 cannot go on the whisper. That's true. That's true. You're very smart, Andrew. So one of these 2 is a 5, and one of these 2 is a 5. Unfortunately, 5 can go in these 2 cells. 5 can't go there. 5 can't go here. 5 can go here, unfortunately, so 5 is not here or there, of course, because 5 is not a low digit. But this can't be a 6 or a 5, I guess. Should notate that. This can't be 2 or 3. Can it be 4? No. So this is 0 or 1. This can't be a 5. Could be a 6 if this was 0, 1. Okay, let's think rationally here because I have missed obvious things several times in this puzzle already. So let's not try to miss more things by... Oh, this can't be a 5. Why did I see this one can't be a 5, but this one just completely ignored that? I think I was looking at where 0 could go in this box, and I didn't really register this at all. Unfortunately, I think this could be a 5. No, it can't be a 5 because this would be a 0. And that definitely does not work. So this can't be a 5 either. And this can't be a 5. So 5 in this box is actually pretty restricted into those cells, which means that 5 is a line, meaning that there's no 5 down here. So 5 is down here, and we have these pencil marks which tell us that 5 is here. And that could be an S cell. So we'll leave it as a pencil mark, I guess. 5 is in one of these two cells, but it can't be here because that would be double 0. So this is it. I keep reaching to put the 5 in, but it could be an S cell. So just hold off. These can't be 5s, that can't be 5. So this is a 5. So there's a 5 here. No 5 there, 5 here. All right. We placed all the 5s except for an X-wing on 5s. Yes, Andrew. Yes, you pointed that out. I can't believe I missed that completely. Yes, this one as well would also require 2 zeros in the box. Yep. So the rule is stop overthinking things and just solve the puzzle without thinking like, oh, what if this is a 3 or whatever. Just try to solve the puzzle. I'm sure it will go fine. So 6 is here. So there's a 6 in one of these 3 cells. Could be a 6 here if this was a 0, 1. Similarly here. Oh no. See, this could be a 1, 1, 6. So I don't think we've narrowed down the 6 options here at all. There's still like 3 places for 6 here. This has to be a 7, 8, or 9. That can't be a 9. That can't be a 9. Why is that? Wait. Remember, like, I don't know, 20 minutes ago when I said if this is a 9, then this can't be 4, and I pencil marked that, but then didn't follow up with it? Yeah. We're here now. This is definitely a 4, but I don't know if it's an SL or not. In fact, it almost certainly probably is an SL. One of these two is a 4, and it's not this one, so that is a 4. Do we know? We know for sure this is not an SL because if it was, then this couldn't be a 4. We know. So there's an SL down here, so there's no SL over here. So what's the probability of this being an SL? Well, none of these digits can be 9, and none of them can be 5. So they are 6, 7, and 8. And that one's not a 6, so the fact that there's a 6 in one of these two means there's a 1. Well, we already know there's a 1 in one of these two because of that. But that means that one of these two is a 1 or a 0. Unfortunately, this one can be a 0. Otherwise, oh, but that forms a virtual 0, 1 pair in the column, which means something. I've just noticed these two are looking at this as well. So this is 0, 0, 1, or 4. Now, if it's a 4, this has to be a 9. Is that a big issue? Well, there's no 9 looking at it, so probably not. But doesn't seem to be an issue, at least as far as I can see. This is 5, 7, or 8. And have we determined that this can't be a 6? If this is a 6, this is a 0, 1, and this is a 6, and this is a 1. Which doesn't seem... Yes, column 6 already has an SL. And row 4. Pencil marking all line cells? Oh god. Probably would help, but I suppose this can't be 4. So it's 0, 1, 2, 3. And this can't be 4 either. So it's 1, 2, 3. And there's a 4 down here, so that's not a 4. So 4 in this column goes right here because that's also a 4. So 4 is not there, or there because of this 4, and our pencil marks. So that's a 4, which is on top of a 5, which seems a bit suspicious and is an SL. That's an interesting step. I don't think I've seen like an accidental SL sort of step before. Whoops, stumbled on this SL. So what does that do? That means this can't be an SL, because if this was an SL, then these two cells would have no fill. So that's not an SL. So one of these two is an SL. So these are not SLs. So one of these three is an SL. Oh, that stopped. I thought that was going to keep going. This, okay, so this is 6, 7, 8. Let's just pencil mark all the cells. This is 0, 2, 3, 4. No, it can't be 4. This can't be 6 or 9, so it's 7, 8. 7, 8. Oh wait, I just realized something. Look at column 6. There's a 2, 3 pair. Don't know where, when that occurred, but that means that this cell can't be a 2, 3, which is very important because that means the 2 and 3 must live in these two cells, which means that this cell is an S cell. So this cell is not an S cell, which means that this cell is an S cell, and that already has a 0 in it. But it could also have a 5, but this cell already has a 4 in it, and it's not an S cell, so it is a 4. Very nice. Okay, so that means that this is a 0, 5 S cell, which I feel like we stumbled into again, which means that this is not 5, and this is not an S cell, and it is 5, so it is 5. These are the sorts of things you get to say in SL puzzles. It is a 5, so it is a 5. Sorry, my cats are playing, distracting me a little bit. This is 1, 2, 3, 4, 4. I think it can still be 4. Just notice there's a lot of low digits here. Not an exuberant number of them, but enough to sort of catch my eye. Okay. There's not a lot of low digits in this row that are marked, at least. Well, I mean, there's 3. That's only 1 more than this one. So maybe I'm doing this row injustice by saying that this pink is like messing with me. I'm like, wait, how can there be 5, 6 pink digits in this box? But pink is not an SL, of course. Row 1, column 6. Okay, yes, I already got that. Yes, okay. Sorry, I will pay way more attention to the chat if it's on a second monitor that I can actively see when it's moving, but when it's like I have to tab away to see the chat, it's just like, oh, it's so annoying. I just want the monitor to please turn on. Okay. I feel much closer than I was at 40 minutes than I am now. Or sorry, much closer now than I was at 40 minutes is what I'm trying to say. I wasn't closer 40 minutes ago. I mean, sometimes that happens when you've made a mistake and you have to redo everything, but not yet. At least not yet. Okay, so let's just continue pencil marking everything in the puzzle. I need to remember no more 5s. The 5s are gone. So this is 1, 2, 3. This is 6, 7, 8, 9. This is, oh, that can't be a, could be a 6 if this was a 0. Annoying. This is 2, 3, 4, 5, or 0, not 5. There's no 5s. Let go of the 5s. This is, of course, all the low digits. Oh, except for 4, because that would, wait. Except for 4. Except for 4. Let's look at 4s. I think 4s might be productive. There's definitely a 4 in here. So there's definitely a 4 in one of these 2 cells. Oh, I just did something dumb. Again, done something dumb. So, done something dumb. Okay. Same thing is sort of true over here. So, oh, this 4. This is a 4. So that gives us another SL we stumbled into. It's not even it's an SL, it just is an SL because there's 2 digits in it. I like that. I love when the SLs are just, oh, this is a happy accident. Yes. Yes, we have done more things. Yes, I think I will have to get better at the skimming if there are more people in chat, which is, I guess that's a good problem to have. You have a good problem there, Zetamath. Welcome back, by the way. Okay, let's hope to stumble into more success here. So this is a 4, 5, which doesn't do anything to these. But trying to think about, this can't be a 6. I know that because there's a 2 or 3 next to it. Wait, we have all our low digits. No, we don't. Ah, I thought we had all our low digits because there's a 4 in here. Do we have any of our, like, any rows where there's all the low digits that we haven't, like, really grasped yet? Is there anywhere where S cells are, like, unhelpful? It feels like with this variant in particular, S cells are more unhelpful than helpful. 4 can't go in row 5, column 8. Yes, of course it can't, because this would be double 9. Of course, and we've stumbled into another S cell just by accident. Okay, so then this is not a 4, which is perfect. That's exactly what I was hoping to do. Thank you, Andrew. That's very, very, very helpful. Very helpful to find. So this 4 saw this 4, which gave us a 0, 1 pair, which removed 1 from here. And this is exactly what I was hoping it would do, because that means that this one couldn't be a 6. So then the 6 moves up here, and that means that these two cells have to be 0 and 1. I don't know why there was a 6 pencil mark in there, but that means that these two cells are 2, 3, and 6. Oh, please don't end. Oh, these cells are all high because we have all of our low digits in the row. And this cell is not an S cell because it would break this one. So these cells can be those digits, which is going to tell us that nothing. Obviously one of these two is, oh, this is easy. This is 7, 8 around a 2 or 3. So obviously it has to be a 2, because if it was a 3, one of these would be a 7 and that would be a problem. Clearly I should color the 2 3s. Oh god, I don't want to color more. There's too much coloring already. Oh, that gives us a 2 here and a 3 here, which tells us that we were right all along. We could have just assumed that, and it would have been easier. But I want to do the puzzle right. So these are 8s. This one is a 7 now, so this one is an 8, and this one is a 7, which means this one is a 2, which means this one is a 7. Oh no, no it doesn't. I did the other way around again. Again, I did that. Oh, we have the 7, 8, 9 quadruple in this box, which means all of these digits are not S cells, which I've just noticed there's an S cell in the box, so we could have gotten that already. There's no S cell here, there's no S cell here. So there's an S cell in one of these two. We're probably going to get this one as an S cell again. This one, 7 or 9. Does that tell us anything? Well, if it's 9, it's not really doing anything. So no, it doesn't. It really doesn't. These two cells are, one of them is, 0, 1, or 2, and the other one is a 6. The other one is a 6. The other one is a 6. So there is a 6 in here, because there's nowhere else to put a 6 in this row, which means that this cell cannot be a 6, because there's already 6 in the box. So this cell is a 6. The 8 in column 7 sees up. Oh, sees the 7, 8 pair. Thank you. That's pretty helpful. Which means that this is an 8. That gives us an 8 over here. So I could have just filled this in and then said that I saw this 7 steps ahead, and no one would question it, I'm sure. I don't think that works as well as I think it does. This can't be 2 or 0. This can't be a 1. Oh, and I was about to say none of these can be S cells, but they're already purple. I keep getting purple and the low-high coloring confused, which is not good, because it makes me think that, oh, this much like this one, sees downwards, like most 8s do, except for some troublesome 8s that don't see downwards. Imagine a Sudoku grid where digits could only see one direction. It would be called one direction. And it would not be a good puzzle, probably. Okay, so there's no 2 here, and there's a 7 next to it, so this is a 1. And that's a 3, and there's no 3 down here. So this is 0, 2. It'd be very nice to know if this was a 6 or 9. In fact, can it be a 6? No, it can be a 6 if this is a 0, of course. This is not a 1. That's not a 1. Wait. What am I saying? These two are connected, so this can never be a 6. Oh, it could be a 6 until just recently, because this could have been a 1. Right. Okay. I'm not as dumb as I thought. Walls. Yeah, that would be. That sounds like you're taking deductions and then taking information away from the solver once you get it. It's just like, oh, you figured something out. You don't get anything. So this could be a 4, but it could also be a 3. I need to not do that. Every time I get a 9 in a German whisper puzzle, I'm like, oh, it goes with a 4. But no, it doesn't. It could go with a 4. There's an option, but it's not necessary. One of these is an S cell. This is definitely a 4 already. And the other cells in this row are 6s and 3s. So there's definitely a 3 over here, and a 6, and 4. Which looks like a ridiculous pencil mark, but it's true. This is 9 and 5. Oh, wait, I already have 5. 5 and... Oh, there's no S cell. What am I doing? There's no S cell up here. So this is literally just 5 and 9. That is quite silly of me. Do I have any other cells where I know that a digit is there and I haven't filled it in? Box 7 already has a 6. Oh, it does. You're right. So that's an 8, which does nothing. There's an 8 up here. Oh, wait, it does something. This 8 fixes it. And there's already a 7 in box 8 as well. So that's also an 8. And have we done all the 8s? Oh, we've done all the 8s. Nice. What about the 9s? Haven't quite done the 9s. I feel very close to the 9s because the 9s have helped me, because they have helped me break into the puzzle. But the 9s now betray me as they give me no information. What about the 2s? Wait, this is a 2 here, looking at a 2, 3, so that's a 3. Things you learn in the day. But 3 does nothing. Well, there's a 3 in one of these 2 cells, and this can't be a 3, so maybe it does something. This is a 9, which fixes all the 9s. This is a 9, and this is a 9. And this is anything. Can be pretty much anything. Fixes the 9s and fills in the rest of the grid. This is a 4-3 now. I missed that. So this 4, 3, oh, this 3 sees this, and then that means that this is an S cell, which has a 5 in it, but not a 4. 5's so sad. 4 is its best friend, and 4 has abandoned it. To live with a 6 or a 3, oh my word. Can't believe 4. It's devastating. Okay, so in this column, we need a 5, which we have. Don't malign my accomplishments. There is a 5. There's 6s, which are placed. This is a 6, because there's 2 6s down here looking at these 2 cells. That was an 8. These are the 6s. So that's a 6. And over here we have 2, which gets rid of a 2 from here. 2 and 7, which is not resolved. But this is a 0 or a 1, which is not resolved. But 0 is down here, for sure, we know that. And there's also a 2 down here, which means that this one is resolved, because this has a 0 or a 2 in it, and that's a 0 or a 2, so this one should be a 3. Which we could have gotten by Sudoku, and in fact there's a 3, 5 in here. So it is 3 that 5 is colluding with. And 6 that, no, 3, what? 3 is colluding with both 5 and 4. This is outrageous. I thought 4 and 5 were their best friends, and now I have no idea what's going on. So there's definitely a 2 in one of these 2 cells, but that doesn't tell me almost anything. So what about these digits? 0 and 1. That was surprising. This digit then, therefore, is known to be a 7, which does nothing. Oh, but this digit, similar to this digit, is also known to be a 7, which places 2 here and 2 and 7 here. And 2 here and 0 here. I was already thinking about this 2 when I placed the 7. This is a 0 and 1, which resolves this 0 and 1. Very nice. Which resolves this 0 and 1, and we're almost done the puzzle. 5 also has a friend in 0. We did know that from the beginning. So that's not as surprising as the 3, 5, 3, 4 collusion, but it's still a little bit unnerving, I think. This is a 6, and this is a 1. And I'm just sitting here waiting for the answer check, but of course there's no answer check because perhaps a thruple situation with 3, 4, and 5. Oh, am I done? Andrew says, row 9, column. Oh, this is a 1. Thank you. I don't know why I pressed 3. I must have been talking about 3, 5, and 4 and got try the tick. Oh, yes. I think it's because I didn't put the the 3 in here. Yes. Yes, Andrew has the key, is that I didn't actually solve the puzzle. Yeah, okay, so I will set that one aside and log my solve later. And what should I solve now? Maybe I will try double dip by zetamath. I haven't refined my puzzle selection process, but I think in the future I will have some kind of voting system for puzzles, in terms of not voting system as in Patreon or anything, but like voting as in the chat votes for the puzzles that we do. I have a list of puzzles that I want to do, and then you vote for, I maybe give you 3 choices or something, and then you vote for the one that you want to see me do. But this is a deconstruction, which means that we're putting a set of 9 3x3 boxes, sort of like these in the puzzle. And then we're also, and there's going to be some empty cells because this is 11 by 11. I'm actually setting one of these right now. And as well, it says that the clues in the grid are double arrow clues, which are lovely things. So if you put a 1 and a 2 in here, then these 3 cells have to sum to 3, because that is the sum of these 2 cells. And of course, these cells can't sum to 3, so if you put 1 and 9 in here, then these 3 cells have to sum to 10, and you could do that in, say, 1, 4, and 5, and that would work, and it's okay to repeat digits along this line. Another example it gives here is if the circle contained a 4 and an 8, then the line could contain, well, this is not a 4-cell line, so that's not a very good example. For this one, I swear, if there is no 4-cell line in this puzzle, I swear if there's no 4-cell line. Okay, there it is. 4 and 8. 1, 2, 2, 7. I thought you were trolling me by not putting a single 4-cell line in the puzzle, but having a 4-cell line example. For your birthday stream. Oh yeah, I do remember that. I took that puzzle and made it easier because it was a little bit too hard. And then made what's it called? Sardines, which has a bit of similar logic. Maybe I can pull. No, I don't want to pull them up. Let me think here. So what did I cover so far? Right, I was talking about this. And then the other thing is that of course, there's going to be some empty cells. So if we put a bunch of 3x3 boxes in here, of course, if we put 9 3x3 boxes, that's 81 cells, and 81 is not equal to 121, which I think is 11 squared. Yeah, probably. So there's going to be some empty cells. And I see that this is already broken. So I'm going to put that box here instead. And the thing that I want to talk about, because there's going to be some empty cells, there's going to be some cells that have no regions attached to them. Of course, you can't fit a 3x3 box above this yellow region here. So these cells are not in any region. And if there's there's a double arrow where there's some cells that are not on any region, they just aren't a digit. They're just no digit at all. And what you have to do is now you have to treat, if one of the circles is gone, then you have to treat this like a normal arrow. So this digit sums to these two. So this could be 7 and 3, 4, or whatever. And this digit, of course, doesn't contribute to this total now. Okay, the other thing that it says in the post is that this digit, this digit, this digit, this digit, right, so I keep saying digits, these cells, I'm not going to color that, I'm going to color that. I hate when that is followed by that. It bothers my brain for some reason. So these cells that I've highlighted in different colors for some unknown reason to some of you maybe, are in regions, and they are digits. In fact, they are basically the boxes 1, 2, 3, 4, 5, and 1, 2, 3, 4, all the way to 9. I don't want to list all the digits because I'm lazy. But yeah, these are always cells, and this is just true of any deconstruction puzzle like this, where there are 9 3x3 boxes. The proof, not a rigorous proof, but a proof that I thought about just the other day, is that if you try to pack these things in as much as you can into the 9 by 9 in this corner. So basically what I'm trying to do is I'm trying to pack these in as much as I can, right? All the 9 boxes, I'm trying to pack them in, and I'm trying to pack them in so that we get as far away from this corner as we can. Now, as far away as we can get means that this cell is still a part of a region. Now, if we do that for any other corner, if I try to get as far away from here, then this cell will still be in a region. Now, the other way to think about this is that we only have these two rows or columns of sort of wiggle room. So if you think about this arrangement, and we're using these boxes as sort of like, we can slide them around easily, I can only ever slide this box 2 cells to the right, or 2 cells downwards, or both. And no matter what I do, no matter how I slide this, and that's because there's always 2 regions below it, no matter how I slide it, since I can only use 2 rows of wiggle room, I will always have this cell in this region, no matter how I slide it. All right. Not really a rigorous proof, but every double arrow clue also has a cell. Yes, that's true. It says here, oh wait, that's the last line. I didn't scroll all the way down. No double arrow clue is left entirely empty. So I couldn't build my regions like this, for example. If I were to go to Zeta and say, hey, I've finished the regions, they look like this, Zetamath would say, can you please read the rules again? Because this is not on any region, so all these cells would be vacant. There would be no cells, no digits at all on here. So that's breaking this last rule here. All right, so let's get going. Only took me 8 minutes to go through the rules. And a proof, a non-rigorous proof, but a proof. I will scroll to maybe here in the rules. I think that's the most relevant place because you can kind of see that it's a deconstruction just by looking at the grid. So I'll just scroll to here and let's think about this. So this is a very long line. In fact, that's a 7-cell line. Now, you don't need to be a genius to know that if you add up the digits, the lowest digits you can, 1 to 7, you're going to get 28. And 28, here's another knowledge bomb or whatever. 28 is definitely not the largest you can get in 2 cells. The largest you can get in 2 cells is 8 and 9. But these 2 cells add up to the same as these 7 cells. So something needs to give. Either these need to be larger or these need to be smaller. Well, these aren't going to be larger because they can't be. I can't include more cells and I can't make them larger than 8 and 9. So that means that there needs to be less than 7 cells on here. Now, usually in a Sudoku, we can't just cut away some cells, but in this Sudoku, we actually can cut away some cells because we can move these regions over so that they don't, say if that cell didn't have a digit in it, this region could go that way, for example. So the interesting thing to note here is that red, no matter how you do red, it's always going to take 3 cells in a row in this row. So it will take 3 cells plus these 2 cells, which means that in this row, these 5 cells, at least 5 cells, will be on this line, which add up to, at minimum, 15. Now, could I make yellow go to the left? Well, if I made yellow to go to the left, then, and I made green go all the way to the right, because we know we can't have 7 cells, it's 28, and 28 you can't do in 2 cells. Well, if I made this the case, then that would be 6 cells on the line, and 6 cells adds up to 21, which is still too much because we can only add up to at most 17. So in fact, we cannot let yellow go left. Oh wait, we cannot we cannot let yellow go left. Jeez, why is that so hard to say? We cannot let green go right. Wait, yes, right. So then these two regions must take 3 cells in their row, just like red had to. So they will come all the way over. And red could take these 2 cells or take these 3 cells. But we know that the minimum that these 2 cells add up to is 15, so therefore they must both be digits. And in fact must be 6, 7, 8, 9, and that's enough to sort of pencil mark them. Yes, reading the rules is absolutely the worst part of streaming. I realize this now after I streamed for like an hour and a half. It's much easier to do on a Discord streaming where you're like, oh, I'm streaming this for 2 people and they already know the rules. So yeah, this is much harder to do. Okay, so this digit is pretty, actually wait. So these add up to a maximum of 17. So could they miss out the digit 1? No, because if you think about it, the triangular number for 6 cells is 21, because 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. So 21 minus 1 is only 20, and 20 is not big enough, or is not small enough to be 17, of course. It's not equal to 17. So we have to have a 1 in these cells. We also have to have a 2, because again, 21, and then we subtract the 2 off, that's going to be 19. And 19 is greater than 17. We also need a 3, because again, 18 is greater than 17. So we need 1, 2, and 3 in here. So how big can this be? How small can it be? It can't have a 1, 2, or a 3. So could it be a single digit? Could this cell not be a digit in the grid? Well, I would say no, because you would say maybe you could do 4 or 5. Maybe you could do 4 or 5, and then that would add up to 9, and then we could say this is not a digit. But 4 or 5 here means that this is not increased by just 1. It's increased by a lot more than 1. It's going to be 1 plus 2 plus 3 plus 6 plus 7, which is 19. Way more than 17, 2 more. And that's because we've increased the degrees of freedom by 2 by taking 2 low digits from here. So in fact, this digit also has to be in a region. And I'm trying to think, does that mean that it is a specific number? Does that mean that it joins green? I don't think I can answer those questions right now. So I'm going to mark it as a circle. I mean, it is a circle, but I'm going to mark it as a circle to say that it is in a region, but I don't know what region it is. I guess I could just mark it as... I guess I could just do that. No harm. All right, so this is also very interesting because this adds up to 1 cell. And this, as we know from our proof at the beginning, this is a digit. So it is going to be at least a 1, and 1 plus 9 adds up to 10. So we can't put 10 in here. That's definitely not going to happen. So this can never be a 9, because then this would be a 10, at least. So this can't be a 6, because these add up to at least 15. And if we put a 6 here, that would be an 8, and that would be 14, not 15. So this one cannot be higher than 3. right? Because if this is as low as it can be, it can be a 6. And 6 plus 3 is 9. And if we go higher than 3, we're going to get to 10. And then this digit will be a 10 again. So this is 1, 2, or 3, which gives me interest about this. Oh, sorry. Gives me interest about this. There is, I was going to say there's no way that this cell has no digit in it. But then I thought, wait a second. If that digit did have, if that cell did have a digit in it, then this would be the case. And this is big alarm bells in my brain, because this means, remember from before, we looked at this, 5 cells. What does that add up to? At least 15. So that would mean that these two cells are a lot like these two cells in that they have to be 6, 7, 8, and 9. But this one's 1, 2, 3. So that's not going to work. So this one is actually not in a region. Whew, that's interesting, because that says that something on this line, which must exist, there must be, it says no arrow clue is left entirely empty. Right. I think I gave in my example that this one was entirely empty, but also that means that this one has to have one of these cells on it. You can't have all these cells blank. It says that at least one of the cells on the line and at least one of the 2 circles is part of a region. So we can't do that. And this is a really low sum. In fact, there's no way this could be 1. Because if this is 1, then we have to put a 1 on here. It would just be like sort of a palindrome sort of effect, or a clone effect. And if you put a 1 on here and a 1 on here, how on earth are you going to build a region? Because that would require, say, these 2 cells to be empty, because those cannot be 1s if this is a 1. But then this blue region can't ever get down there, and neither can this green region or this orange region or any of the regions can get down there. In fact, this is too small for a region to get down. So that is not possible to be a 1, and in fact, for the same reason, it can't be a 2. Because if we put a 2 here, then we're going to have to put 2 1s in here, but we can only ever fit 1 region down here, and that's blue. So there's no way that this is a 2. And we have to use 2 regions because we need 2 1s to add up to 2, or a 2, and that's, the 2 is the same problem with a 1. You wouldn't be able to fit 2 regions once you blacken out those cells. And if you wanted to put, say, a 1 over here, then you wouldn't be able to fit another region over here. So this is definitely a 3, and there's definitely going to be a 1, 2 here somewhere. And it's either going to be here, or it's going to be here. There's no way that this is blank. If this is blank, well, actually, let's just go with the easy one first. This is definitely not in, because then I would have to make these 4 cells add up to 3, and that's not going to work. So that one's definitely empty. This one, also empty. For a similar reason, if I include this one in this region, I'll have to do that. These 3 cells cannot add up to 3. So that one is gone. So now one of these little legs is in, and that leg is a 1, 2. That's not a 3. But this is always blue because one of these legs will have this cell, both of them will. So this is also a 1 or 2, and we can have a 1, 2 pencil mark here. And I know, well, let me illustrate this point differently. If I block off blue from this side, how am I going to finish blue? Well, if I take this cell, well, blue's done. It's not a 3x3 box, so it's not going to work. If I take this side, well, I can't extend it further here. It's not a 3x3 box, so it's done, and it's broken. So blue must extend 1 to this way, and that means these 2 cells are in, and there is I was going to say there's no way that this is no digit, because because this being a 1, 2 seems ridiculous, but, oh, yes, of course it can't be a 1, 2. If it was a 1, 2, then there would be 4 digits in blue, which are 1 and 2. I don't think 4 digits in a region being 1 and 2 is going to work, so this one has to be part of a region. It can't be part of green, it can't be part of blue, so it must be part of orange. No worries, both of you. Oh my word, I'm trying to just peek at something and... Okay. So now it's really interesting because this digit, or sorry, these 2 digits add up to something along here. It could be 3 digits, it could be 2 digits, but it can't include a 1, 2 in these 2 cells, or a 3 even. So it's at minimum going to be 4, 5, which means that at minimum this cell is a 6. Now it could be greater than 4, 5, much greater, but it at least is 4, 5. Can it ever take this cell? Yes, it can. Well, could it? Adds up to 12, right? So it adds up to 12 maximum, right? So could these 3 cells add up to 12 without using 1, 2, or 3? Well, 4, 5 plus 6 is 9, plus 6 is 15. 15 is not equal to 12. So in fact, this cell is always not a digit, which forces blue to do this exactly. Definitely not that one. This. And that digit will be 9, 8, or 7. Wait. No, it won't. It's going to be 9. This is a 6 and this is 9. This sat here for a long time. Well, I know I don't have an active screen because no one even mentioned that. So this is it's definitely a 6. And this is definitely a 9, which means these do add up to 15. So in fact, now we have 4 and 5 in here as well. A little bit of over pencil marking here, but we can probably just, I'll just fill in these 3 cells and then get rid of those entirely. And we know that there's 5 cells here that add up to 15. So these cells are going to be 6, 7, 8, 9. Now, what is the minimum that these can sum to? Well, they're going to minimum sum to 15 because, or sorry, that was stupid. They don't minimum sum to 15, maximum sum to 15. So minimum sum to 13. So this is a minimum of 7. This can't be a 9. This obviously can't be a 6. I don't know. I thought these had to add up. I thought these had to add up to 15, but they definitely do not have to add up to 15. That's definitely not true. I made that up. But these are definitely green because they can't be blue or red now. So green is trapped here and is actually fixed in terms of its shape. So now we have a 6, 7, 8, 9 triple, which means that this is not 6, and in fact, they do add up to 15. And I saw this a million miles away. So these are not 7 or 8, so this is the 6 and this is a 9. And these add up to 15 because if you put a 7 here, these will add up to more than 15. And that would mean that 13 adds up to more than 15. So that's definitely not true. The other way to see it is these are minimum of 15. So this has to be 15. All right, so there is definitely a 6 over here. And this is sort of like a little arrow now. This digit adds up to these 2, but it could be completely empty because these are the same digit. Oh, wait. The other thing to note here is that yellow definitely does not come down. Because if yellow came down, there would be 2 9s in that region, which is definitely not going to happen. So yellow is completely forced in its shape. Very nice. So orange has to come up because it just does. This has to be green because it can't be anything else. Okay, so what does that mean? That means that well, that's definitely black. Those are black. These are black. Or not digits, or whatever you want to say. And that's just because of this cell. So we've run out of easy things. I've run out of easy things now, so I need to look for hard things, I guess. It's definitely a 3 in one of those two. Okay, so let's look at some of these other double arrows. Maybe this one. Because that's a lot of cells. That's 6 cells. So not all of these can be in. But I didn't really want to put them all in. So don't know how important that is. This next, oh, okay, so this is orange because, why did I talk about this before, but not when it was actually useful? So these are essentially an arrow now, because this just itself. So if these cells are in, because yellow's shape was fixed, then this cell must be in. Which means that I'm not sure what that means because this could be a lot of things. It would be nice if this had geometry to it, like this digit couldn't be, if this arrow turned a little bit, then we would know that this digit is over here. Probably, I mean, it could be there, but if this digit turned that way, it would be interesting from maybe a setting perspective more than anything. Oh, maybe this line. 3, 4, 5, 6, 7, 8. Well, I know that all of these cells down here are not in. So either, okay, so it could be 5 cells and sum to 15, which wouldn't be that restricted. It can sum to maximum 18. Because of these, this could be double 9. Oh wait, why did I push orange up but not push orange over? This orange goes over, so this green goes over, so green's entire shape is fixed, which I didn't notice. How odd that I didn't notice that an entire shape is fixed. Oh, you know what is sus? No. It's not as sus as I thought. Actually, these could sum to less than 15 because they don't see each other. This one has to come up one at least. And it has to come right one because it needs to take at least one cell on this line. Maybe I should think about that. So, I was thinking about this. What about this? Because I'm wondering if purple has to take one of these. Because, wait, no, purple just has to take this. Wait, does it have to take that? Because if it doesn't take that, then why couldn't yellow do this? Seems reasonable that yellow could do that. Bit stuck now. Not got a deduction for a few minutes. So let's think more about Sudoku, maybe? Yes, Sudoku. Yes, look at these 9s. Now, can red live here? No, it can't. Because these 9s... Oh, wait. It's even better. It's even better. Because can red live in here? No. It can't. Because it can't have a 9. And it can't live in here because it can't have a 9. So it must live above this line. So red comes all the way up. Wow. Okay, that's the sort of deduction that I wish I could force in some puzzle. Very nice. Up 2 cells. Oh. Okay. And it takes a 9. Ooh. And it takes a 9 in one of these cells. Now, if it was in one of these cells, that would be really interesting because that would mean that both of these had to be in. I don't actually think that's possible. If red does this, 9 is on the line. So both of these cells must be in because you can't have a single digit total with 9 plus 2 cells, of course. So if red is like this, then both of these need to be in, but what on earth is going to take this? Nothing. Nothing can squeeze into this little corridor, so red does not do that. So red takes one of these cells. In fact, if red came over, no, sorry, if red, I don't know why I think that way. If red came over here, it also couldn't take a 9 on the line, because that would mean that both of these would need to be in, but only one could be, because again, something can't squeeze down here. But that doesn't mean red can't come to here. It just means that red can't have the 9 on this line if red is over there. So red can't ever have a 9 here, because the other option is it comes over here and has a 9 on the line, which would mean that this could be yellow. Could be yellow. Yeah, and then that would be fine because you could have 2 digits which add to 9 plus another digit. This could be like 1, 9, and 2, 8. Okay. Not quite there, but very, very close. That also means that red does not come down which means that this entire row is black, because orange can't ever get up there. This is also black. Now either this is black or this is black. Oh, you know what is interesting? You know what is very interesting is that red has three of 1, 2, 3, 4, and 5, which means that these cells, which are definitely going to be in red, like a lot of them, 4 of them, can't be a very low number. I mean, they could be 1, 2, 6, 7. That's the lowest you could get. 1, 2, 6, 7. So that's 16. 16 is the lowest possible division of 2 of this number. So you could have one of these add, you could have the single 9. So this would be possible, because that would imply this is a 9 and this adds to 18, which it can add to 18. And of course that would mean that these digits are not on the line as well. So let's look back at this, because this is a high digit and a high digit. And if this and this is a high digit and a high digit. High digit and a high digit. Oh, no matter what happens with this, whether orange goes up or orange goes down, there's always a 2-cell sum, either here or here, which has to add up to this digit plus this digit, or this digit plus this digit. So we always need to do at least a 2-cell sum. Or sorry, there always is a 2-cell sum. And this digit can't be higher than 5. Let me actually mark these. 1, 2, 4, 5. These are 1, 2, 3, 4, 5. And there's a 9 in yellow up here. There's a 9 in yellow on the line. So this is yellow. Is that true? Yes, that is true. Okay, this is true for a sort of weird reason that maybe not everyone knows. But okay, so look at this. Before I extended yellow, there would be 9 digits in this column. So there needs to be a 9 in this column, because there's 9 digits, and digits can't repeat in a column. And there's no 9s in these cells, or that one because of this. So there needs to be a 9 up here, which means that yellow must have that 9, and these 2 cells cannot, or sorry, this cell cannot add up to itself plus another digit at least without taking this cell, so it must take this cell as well. So that means that yellow can never come here. And if yellow can never come here, then red coming here still means that this can't be a 9. So that's not a 9. This is my, I like to have a little pet project within the grid of any puzzle I solve, and this is my little pet project. I really want to prove where this red goes. I really want to say it goes this way or this way, and the fact that I could eliminate this 9 made me excited. Good job, Zeta. I wish you could turn the pen tool so that it only does one type of thing, because I really only want it for edges most of the time, and edges that are literally on the edge, not weird edges, just I don't need that. I don't need that. And I don't really need that, and I don't need this either. Just edges, please. Could this take 4 cells? Yes, it could if this is a 7, 8, or a 6. In fact, we have all the low digits, so this is 6, 7, 8. Well, I guess it is a 6, 7, 8 because it is a 6, 7, 8. So this digit plus this digit add up to these two digits. So how could this be a 7? If this was a 7, I would say that 16 is equal to 14. That doesn't work. So just like this one must be 15 plus 15. 15 equals 15, sorry. These are black. And this either comes over here or pink comes over here. Hold up, can that ever be a 9? I don't think that can ever be a 9, because neither of these cells can be in anything but red. So this is not a 9. And in fact, red takes one of these cells, and the sum is 9. So there is 4 cells, and they do add up to 18. Do add up to 18. So if there's 4 cells and they add up to 18, and they don't include a 9, there's a few ways of doing that, I think. There are 3 cells which are from 1, 2, 3, 4, and 5 in there as well. So you couldn't do 1, 2 because that would not have the higher, that wouldn't actually be high enough. So this can't be a 1, 2 pair. Ah, this is bothering me now. I feel like I should get this, be able to get this. Okay, maybe that's not where we're supposed to look. Maybe we're supposed to look in this column. Or maybe it's a 7 or an 8 down here because of this. This one must be down here because it can't be up here. So this is 9, 1, 2, 3, 4, 5, and it can't be 1, 2 because of this. So it's minimum, wait, it sums to 15. So the digits with 9 sum to 6, of course. We literally have the 6 and a 9. So it can't be a 3. Oh, it can't be a 3. This is nice. This is really nice. It can't be a 3. So where does 3 go in the column? It doesn't go down there, and it doesn't go up here, so it goes right there. Very beautiful. So there's 2 sets of digits which add to 9. And now this one can't be 3, 6. So it's either 4, 5, 2, 7, or 1, 8, I guess. What was I saying before? Of course you could do 1, 2, 7, 8. Don't know why that... Why did I think you can't do 1, 2, 7, 8? Mysteries of the universe, but I just noticed that there's a 1, 2 virtual pair here, so this is 4, 5, 7, 8. Oh, we don't even need a 1, 2 virtual pair. We have a 1, 2 in this box. This is 4, 5, 6, 7, 8. could be 4, 8, which is annoying. Or it could be 4, 5, which is... How does it have that much range? I guess it's only 3 digits apart. This is pretty low. So if we did the minimum here, 6 and 6, this would have to be 8 or 7. If this cell wasn't in, that is. Okay, a little bit stuck. Is it this? Don't really see a problem with that happening. Okay, so well, is there definitely not a 9 on here? Well, either there's two, there could be a 9 if it was 7 and 8, and these, yeah, could have a 9 on it. So there's a 9 in one of these cells for orange. Should I focus on 9s? Like, I'm struggling to see where I should focus on. Maybe I should think about purple. So something needs to take these cells. Wait a second. Ah, I see. It's easier than I made it. It's easier than I made it. I just assumed that this couldn't be 1, 2, 3 because it can't be 1, 2, 3, and 9 because that would give you a problem with this cell. I believe. So then, oh my word, this comes back to the root of the problem. I don't want that. I just want to do edges, please. Okay, so okay. So obviously purple can't go any higher or lower. So if this cell is not in, then these would be 1, 2, 3, and this would have no value. So this is in. Very nice, very nice. So then this one, we know what these sum to, actually, because this sums to 15, this sums to 30 plus 6, so that's 36. So these sum to 9. So this is a 3. Huh. Very odd. That is a very odd set of deductions there. And there is a 3 on here. So the other two cells are the 1, 2, 4, 5. There's a 4, 5 virtual pair here. but there could be no digits here at all, which is kind of funny. There's definitely all the digits in this row. So, oh, that's clever. Well, that's very, very clever. Wow, okay. So here's what I noticed. There's definitely all the digits in this row, right? There's 9 digits. There's going to be 2 that are red in one of these 2 cells. Let's just say it's these cells, right? There's no 6 over here. There's no 6 over here. So there is a 6 in here, and that's red. But we know that the sum on this, I was going to say between line, this double arrow is 9. It must be 9. And in fact, there's actually 2 ways of seeing this now. I see that this 3 can't be 3 cells, so this has to be a 9, but I'm going to see it the other way because this way is actually really cool. Really cool. So one of these is a 9, and the other one is blank. We know that for sure, because no other region can reach it. So the 6, can the 6 go in here? No, it would have to go with a 3, right? So the 6 is not in there. So the 6 is in one of these 2 cells, but look at this pencil mark. That says that this is not a 6. So this is a 6, this is a 9, and red goes to the right. Now the other thing that I saw was that this is 3 cells, so it can't be 3, so this has to be a 9, but I think the other way was available earlier, and it is really cool, so I need to show it. 4 or 5 virtual pair on no digit. Okay, so that also means this is not 3, 6, so there is a 3 in here, so that's not a 3. Oh wait, and there's definitely 7 and 8 in here. So what I said before, that this is not a 1-2 pair because I miscalculated, it actually is a 1-2 pair. Absolutely is a 1-2 pair. Which means that this is 3, 4, 5. Nope, I did not mean to do that. And these cells sum to these 2. And that's going to be pretty high sum. Actually, wait, let's look at these cells first because we know what those are. Those cells add up to 12. 12 and 3 cells without a 3. It's not that restricted. Put a 3. No, it can just barely, you can get 2, 4, 6 without 12. Because I was thinking 3, 7 is out of the pool, so you need 1, 9. The 4, 6 would work. So 2, 4, it's either 2, 4, 6 or it has a 1, and then it has lots of options. So maybe we need to look at this column, which has a lot of line digits in it. This one also does have a lot of line digits in it. 9 goes up here. Because there's all 9 digits in here, and these are not 9s. So 9 goes up here. In fact, we can say that 9 is in these cells. A bit over pencil marky, but Just wanted to say that there's no 9 in here, I guess, is really the point of that. So can 9 be on this line? I think pretty easily. So what am I missing here? I seriously doubt this comes down. Oh, there's definitely not 9s on it if it comes down, because then you would need these 4 cells. They could add up to that digit though, because they could add up to 8. 4 digits which don't see each other could add up to 8. Oh wait, these can't be 1 or 2. That's a little bit interesting. That's a minimum of 3, 4. So if this was a single digit, it would be 8 or 9. It's not quite there. Not quite there. Oh, can this come over? That is a question. I would say these 4 digits add up to 12, which is possible. I can repeat. It's very possible. Bye, Mathfesto. See you later if I'm still streaming. I mean, these digits, like, minimum sum to 21, but so these digits sum to a minimum of the 21 minus 2 is 19. Minus 9 is 10. Minus 9 again is 1. So these two sum to a maximum of 1. Wow. Really, really effective there. That was what a deduction. Oh, wait. This row has all the digits, but there's no 9 there and there's no 9 there, so there's a 9 in here. There's no 9 in here. Just got rid of 8 instead of 9. Okay. Maybe that is helpful, because if this is a 9, 9 plus 4 is 13, which could be 6 plus 7. Oh, God. Hello. Why, OBS, do you do this? No, I didn't solve it. I got stuck. I got stuck and then I took a break to eat food and drink water. Quick break. No more crackling, okay. I don't know what was going on, to be honest. Yeah, usually recommended, but sometimes they can be avoided if you're Superman, but I'm not Superman, so is this, there's no issues, right? Like, is this all right? I'm assuming. Also, welcome back to Zetamath and Xenonetix. Okay, okay, so there's a 4, 5, a 1, 2, and a 7, 8 in here. And the 1, 2 pairs up with this, which means up here we have a 4, 5, a 3, and a 7, 8. Sure, a hint question would be great. Also, I loved this box, especially the 9s. The 9s were very nice. I don't know if you're gonna watch the VOD back, but when I found the 9s, I said I wish that was a deduction I could put into a puzzle. Like, that's something that I wish would happen when I'm setting a puzzle. Like, it's really hard to force something like that, and I think I've tried a million times. But what would happen if this circle is a 6? Then these have to add up to 12, or these 3 maybe. Oh, but these have to add up to 15, or these would have to add up to 15. Excuse me. Now, these adding up to 15 is really easy. But that would mean, oh, this one. This Hello? 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 I reset the mic. I'm not sure if that worked. It sucks that I have to wait, like... Did it work? Okay, okay, sweet. I just reset the mic, so... That's really annoying. Okay, now I don't know if you heard me or not, but what I said about the 9s is that it's something that I wish I could force something to go up 2 cells in a deconstruction to get a digit. I was playing with that sort of thing yesterday. Sorry, I have a automatic vacuum and it turns on sometimes. Okay, you didn't hear any of that. Gotcha. Okay, so I know. So what I figured out from the 6 thing is that if this is a 6 or 7, this goes up, because this would have to be 1, 2, 3 or 1, 2, 4, and that wouldn't work. But I'm not sure if I catch a drift on anything else other than that. Oh, the line with the 3. I did. So some of these lines, I just started ignoring them. So if this is a 6, this has to be a 4 or 5. Oh, which is broken. Of course it's broken, because, okay, yeah. Yeah, I see it now. I see it now. Very tricky. Well, not that tricky. I knew that there was 1 4 5. If I had colored the 4 5s, then I would have seen this, but I really didn't want to color the 4 5s. So there's 1 4 5 down here. So if this is 7, this has to be 4 6. If this is 8, well, this can't be 8 anymore. If this is 8, though, it could be 5 6 or 4 7. Which is unfortunate. If it's an 8 and it goes down, these 2 digits have to add to 14. So they'd have to be 5 and 9. Hello? Why does this keep happening? I'm assuming it's back again. Okay, I'm gonna... This is very strange. I'm not sure. I'm not sure why it keeps happening. I'll have to investigate this further. I'm wondering if it has something to do with the compressor. Okay, I'll have to read about some of these settings so I understand them. But for now, so I figured out that if this is a 7, then this is a 9, and if this is an 8, then this is a 9. But I don't know how to use that. It's probably something that's like, where does the thing go in this thing? Oh yeah, where does the thing go in this thing? Specifically the 3 thing. That can't be a 3 because the 3 in these 2 rows needs to be in these 2 boxes. So needs to be a 3 in there. There also needs to be a 3 in here. Can't be a 3 there. Yeah, I have no idea why it keeps muting me. There isn't even a mute, there's no mute interface going on when that happens. Now look at the other line. What other line? What other line? The other line affected by this, like this line? I don't know, I think this could be either way still. Maybe this line? Oh, wait. If this is a 7, right? Then it has to go up. We already talked about that. It has to go up if it's a 7 because this can't be 1, 2, 4. But then what is this going to be? Because this goes up, so it doesn't take any more cells. So this would have to be 7, 9. That's not going to work because there's a 9 in the box. So that's not 7, that's 8. Okay. That was probably the hardest stuff in that puzzle, if I'm being honest, but that was good. It's just really hard. Okay, so that can't be a 1. There's an 8 over here. There is... All right, now this has to be a 9. We already talked about that. I think the reason was, well, this has to go down now because there's no way that these two are going to be 8, 9. Right, and that's why it has to go down. So this one has to be a 1. This one has to be a 1. And these two have to add up to 7, which have to be 3, 4, which has to go like this. So that's a 5, which means that there's a 5. There's no 5 over here, sorry. There's a 3, an 8, and either a 2 or a 7, I want to say. Excuse me. Nearly done all the regions. These digits are 2, 7, 5, and 6. That can't be a 4. Oh, these add to 11, so that can't be a 7. Okay, so we're really close to something interesting, I think. Let's think about 8. No. Let's think about something in this row, maybe. No, because all the digits are a little bit 2 free. These two add to 9 though. So, oh, I determined this before, that this digit has to be at least a 1. In fact, I figured out that these two digits have to sum to at least 1 based on maximums. So this digit is at least a 1. So then the 4 is over here. I'm going to mark that there's a 1 over here so that I can see that there's a 1 over here. There's no 9 in here now. Let me think here. So what did we get? We didn't get anything from this. We may have gotten something, but I do not see it. What's the maximum you add up to? Well, these could add up to 5 plus 6 plus 7, which is 18, which is already more than we need. So they don't add up to that, so this is not a 2. But they could add up to, so let's say 2 plus 5 plus 6, because that's sort of the max, or so that's the minimum. That's 13. So the maximum that these two add up to is 4. 4? Really? So if these two add up to 4, then there's definitely a 1 in them. And this can either be a 2 or a 3, because these could add to 1 more than that. With 2, 5, 6 add up to 13, which means these add up to 4. But it could be 2, 5, 7. But it needs a 5, so this is a 6 or 7. Oh, this is a 2 or 3. I wonder which one it is. It's a 2, because there's a 3 in the row. So this one is 4, 5, 6, 7, or 8. Wait, pencil mark that before I forget that there's a 3 in a row. So then this needs to have a 7 in it. So this is a 6. Wait, this is a 6. So that's not a 5, because these two add up to 11. These are not 6s. This needs to add up to 9, and it can't have a 7 or 8 because this would need to be a 1 or 2, so this is a 4 or 5. Getting rid of 4 and 5 from there. This can't have both 4 and 5 on it. That's kind of nice because that means that one of 4 or 5 is up here and one of them is up here. Not sure. That has at least one of 4 and 5 on it, though. Wait, where does... no, not true. I was going to say, where does 3 go in this column? But it could go there or there. Okay, so what else do we need in this box? We need 6, 7, 8, and 3. These are not 6s. This is 1, 9, 5, 2, 7, I guess? Yeah, if this is a 5, there can be a 2, 7 up here. I guess this is 4, 2, 7, 5. And 6, and 6. Don't forget about 6. No 6 at the top there. This puzzle is giving me quite a run for my money. Yeah, or Xenonetix. There we go. Xenonetix. I was talking to Cogito today about deconstruction and stuff, and he was saying like, whoa, like it's not a good idea to probably set like your first thing of like S cells or something in deconstruction, because then you don't get rid of the sense for it. You worry about the deconstruction. And I said, oh yeah, I guess maybe it wasn't the best idea to set my first S cell like using between lines, because that was really hard to do. But I'm glad I did it, because I understood that a lot, or I understood between lines and S cells a lot more after doing that. But I don't know if I would say I'm glad I did it. That was probably a lot of time wasted. I can have 1, 2 up there. This is atrocious pencil marking. I feel like we should know much more than we do. We don't know enough. Oh wait, there's a 4-5 pair, so this is not, that's not 4-5. So this is a 4-5. So that's a 4-5 pair in the box, okay? So that tells me everything about the world, because okay, let's try to do some tricks here. So those are 3 sets of the digits 1 to 9. And I can rule out this set, and that's 2 sets of 9. I already have my 9s. Oh god, why CTC? Why you do this? Okay, I already have my 9s. I already have my 1s and my 2s, sort of. Let's just say this one's a 2. I need a 3 in here. I already have 2 of 4 and 5. This is not helpful. This just tells me that there's an 8 in one of these cells, which is not helpful. Oh, even worse. One of those. No, wait. No, that doesn't tell me anything, because this could still be an 8 with that being an 8. So it doesn't tell me anything. So don't do that randomly. Maybe pencil mark the last circle. Okay, that's a good idea. 3, 4, 5, 6, 7, 8, or 9. It can't be 9 or 6. So it's one of those. If it was a 3, seems very unlikely it is a 3. Wasn't there some reason I said it couldn't be a 3? I said that this could only go here and here. Why can't 3 go here? I don't see why. Not immediately, anyways. 8 doesn't do very much. I think I'm thinking about wrong things, like not useful things. Maybe I should think about sort of thing. This is the double arrow that is secretly a single arrow. Oh, I said that like a million years ago, and then I forgot about it. Right, that's why I said it couldn't be a 3. I recognize this, but I didn't use it. So this can only be a 7 or an 8, which means that it can't have 7 or 8 on it. So there's 7 and 8 up here, so there's no 7, 8 in here. This has a 4 or 5 on it. So if it had a 3, does it need to have a 3? Yes, it does, because it can't have both 4 and 5. Otherwise, it would add to 9, and this would be 9. So this is a 3. And that means that there's a 7-8 virtual pair, so that's not a 7-8. That's not a 4-5. Come on, do something. It's definitely a 7-8 in one of these two. Wait. This 6 from across the universe sees these two cells, placing a 6 here and moving a 6 up here onto the arrow. Oh my word. Okay, so this 7-8, if that's the same one as this, then these two sum to 9, which would have to be 3-6. But if the 9, no, wait, this is a good thought. If this digit is not this digit, then they're one apart. I'm finding that hard to conceptualize for some reason. So that means that either we have to make up 1 in here, so we need to add a 10, or we need to make less 1, so we need to add to 8. So it clearly can add to 8 with 2 6. And it can add to 10 with a 1 9. Oh, but it can't be 1 9. It can't be 1 9. Oh yeah, it can't be 1 9. Because if it was 1 9, then it wouldn't have a 6. So, and there's a 6 in here, obviously. So it's either it is 3-6 or it is 2-6, which means it does not have a 9, which means this is a 9. I thought that was going to do a lot, but I think it just gets rid of 9s over here. There's a 7-8 pair. So this is a 2, this is an 8, this is a 2. Oh my word. There's no 2 in any of these cells, or that one, or that one, or that one. Where's the 3 here? What am I doing? There's supposed to be a 3 in there. Okay, so there's no 7s in here. Trying to like mind read zetamath right now. Oh no, have I broken the puzzle? Yes, I have broken the puzzle because I put the wrong digit down here. This is a 7. It was supposed to be the other digit, not the 2. I knew what I was trying to do, but I did the opposite. Yes. Yes, I saw it, zetamath. Don't worry. Don't worry. I knew what I was doing, but I did the opposite. I feel like this should have helped, like, way more. Now, what can we do? We can say that there is an 8 in one of these cells, which is kind of a weird pencil mark. There's either a 2 or a 3 up here. I want to know which it is. If this is double anything, if it's 8 and 8. Wait a second. What was 2, 6 a part of? 2, 6. 2, 6 was when you did. I should just, so 8 plus 8 would be 16, right? So this would have to be, wait, so this would have to be an 8, and this would have to be a 7 for this to be a 2, 6. I think there's a problem with that, but I just can't put my finger on it. Yes, there is a problem with that. This is a 2. No, wait, there's not a problem with that. Because then this would be a 2, 7, this would be a 1, 8, and that'd be fine. There's definitely not a problem with that. You have all but one cell. Which double arrow? This one? I don't know what that joins. Unless there's something else. I'm not saying. Because like these could easily be 12, I think. Well, they don't have a 2 anymore. They don't have a 2 or a 3. So they definitely need a 1. Because 4, 5, 6 is too much. So they definitely need a 1. They need a 1. If this cell is gone, they need a 1. So they add to 11 now. 11 in 2 cells. So it would have to be 1, 4, 7. Is that supposed to cause me distress? Lower left-ish. It joins. Oh! Yes, you're right. This is a 5. Okay. Thank you. Thank you for sparing me from my complete ignorance of the actual like clues in the puzzle. So the fact that this is a 5 means that's a 4. So there's a 5 over. I actually have done this before. I have done this. The 5 sees these cells and none of these can be a 5, so the 5 must go over here. I have done this in a puzzle before. Did that in Motel. That is a good way to end a puzzle, I think. So that can't be an 8, but it can be a 5. I'm not going to pencil mark that because it's 5, 3, 2, and 1. Which means that there is a 1. So that's not a 1. So 1 over here. No, 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 you're not cruel. You're not cruel. I have not made... Am I making you out to be cruel? I'm sorry. We're in 1 and would need to be an 8, but couldn't be. I don't know what that means. I don't know what that means. Oh, but oh wait, I just said 2 seconds ago that if this cell was gone, then this would need to be a 1, 4, 7. Thank you. Zetamath. Oh, it is a 147. Oh. Yeah, it is. So that's a 7, so that's a 1, that's a 7. That's a 5, 6, which means that's a 9, that one. Not the one off the grid. So that's a 2, that's a 5, off the grid. He has no identity. So now this is not 7, this is not 7, this is 8, 4. These are not 4s. This is an 8, right? Okay. This is an 8, this is a 7. Which means that these are not 1s. This is not a 1. So 2, 3, 5 triple. Scanning, this is a 9. So this cannot be a 5 because that would need to be a 1. So, come on. Oh, just give me 1 second. Hello, sorry about that. I'm back. uh, just my fiance calling me because she's like not coming home today between work, two different jobs. So she wanted to tell me about her day. Didn't realize I was doing something. But it's all good. Yeah, we're near the end of this one. Hi, hey Matt Pesto. Good to see you here again. We're really near the end. I think, at least. Hope there's no tricks at the end. Gonna be here for another hour. I think we figured something out. And I think it was gonna, like, completely devastate the puzzle, but now I'm okay, so if this is 4, right? Then this is 3, so this will be 2, so this is never 2. Similarly, if this is 5, this is never 1. Wait. Yeah, this is never... Wait. Yeah, this is a 1, 2. Yeah, because 4 and... No, I think this could be 1, 3, 5. Yeah, that works too. So not quite, but I just noticed that this 6 sees over. So that's not a 6, so this is a 6. That didn't do anything. Looks like the next place is top column where the sum is 17. Oh, 9. Sorry, 9. This sum is 17. Right, I got this 8. That's what I was saying. It's gonna break the whole puzzle apart. But yeah, I didn't. So this has to be a 7 because these can't sum to. They can sum to 9. Oh, that has to be an 8 then. Getting it backwards in my head. So this does sum to 17 now. So this, now we can remove that 5, remove this 1 that we just put down there. This 3 gives us a 3 up here, which means that this is 4 and 2, which means this is 5 and 1, which means that this cell is going to be a 5. This is a 2 and a 1, and no 2, that's a 3. That's not a 2 or a 3. These are not 8, which means that this is 7, 1, 7, 2, 8, 2. Wait, this is an 8. I was like, where is the 8 in this row? I spent so long looking for that. Okay. Oh, that was a bit embarrassing. 7, 8, 8, 7. Very nice how these disambiguate at the end. Deconstruction is so weird sometimes. Oh my word, I keep messing up. Is that it? Is that the puzzle? Did we do it? Is it working now? Hello, 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 hello. Better now? Okay. Don't know why it keeps doing that. Let's go into Sudoku recommendations and yeah, let's try I'll end with this one that you recommended, Math Pesto. See you, Zeta. Yeah, no worries. This looks familiar. So there's a between line. Okay, so let's talk about the rules first, obviously. So this is a between line, so the line has to contain digits which are between these two cells. So if these are a 1 and a 4, this will have to be a 2, 3. And these purple lines have to contain consecutive sets of digits. So for example, if this was a 1, this would have to be a 2. I just started hurting for some reason. If this was a 4, this could be a 3 or a 5. And these green lines have to be German whispers, which we've already looked at this stream in this puzzle. But these are a little bit easier because these are just the normal digits. So if this is a 1, this could be a 6, and this could be another, well, this couldn't be a 6. This could be a 7. This could be another low digit. They oscillate in parity, of course, like everyone I'm sure in this chat understands. Okay, so let's get going here. So I've immediately noticed that these are different parity, of course. Maybe I'll do, so then the German whispers are of course always 5 different at least, right? So if, but these, so these have to be 5 different, so these have to be at least 7 different, because if this is, say, not 1 and 6, but 2 and 7, for example, then the minimum these could be apart is 1 and 8, which is 7 different. So actually these only have 2 options each, really. They're either 1, 8, 1, 9, 2, 9. That's it. There's 3 sort of options, which means that these have to be within that range. So they could be 2, 7, could be 2, 8, could be 3, 8. Can't have a 4 or a 6 or a 1 or a 9, of course, because you can never put a 1 or 9 on a between line. I think I'm gonna have to return this mic. Like, it just keeps muting me for no reason. Which is just awesome. Maybe I need to close Discord. Maybe Discord is causing mic over sort of issues. Yeah, I know how to fix it. I just restart my mic, but it's I'm not doing anything to stop it. Unless there's a hotkey. Maybe there's a hotkey I'm hitting. I don't, like, it's not showing that it's muted in anything. Is like they're a hotkey for YouTube streaming? Yeah, it might be Discord, it might be a hotkey. I'll have to play with it a bit. But if this is a 5, then even if this is as far away as a 9 or a 1, then these two cells will have to be between 5 and 1 and 9, which means they have to be the same parity, but they are by definition, as I've labeled them, opposite parity. So this can't be a 5. And if this is a 4, I think we get into the same problem. Because even if this was a 9, just ignore this 9. Maybe we'll just do 6 and 1. Well, I guess either end is symmetric in terms of that. But if this is 6 and 1, then you still don't give it any more room, because all you're doing is allowing a 5 on the line, but you can't put a 5 on a German whispers line. So there's never going to be a 6 or a 5 or a 4 on these ends, but this is a 3, 4, 5, 6, 7 cell line, and if you look at the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, and you imagine them on a 7 cell string, well, if I take the first 7 digits, then I always take 4, 5, 6, and if I take the last 7 digits, I'm going to take 4, 5, and 6. And actually I take 3 and 7 as well, but I always have 4, 5, and 6, and those digits are definitely not on these ends, so they must be in this box, which means that these can't be 4, 5, and 6, which means that, and there's 3 of them. That's actually really interesting, because if there's 3 of them, then we're actually looking at this parity thing again, because we can't have a 1 or a 9 on the ends, or, well, of course we can have a 1 or 9 on the ends. We can't have a 1 or 9 on the line. So how many low digits can I put on this line now? I can only put 2 and 3. So there's going to be at least one of the opposite sort of high-low parity. So these two are opposite high-low parity, which means something. Welcome, wooferfg. I am using OBS, but it's strange. I would appreciate you doing that, Xenonetix. There we go, Xenonetix. I don't know why I keep saying Xeno. I think that's how I think of you in my head for some reason, but not in that way. I'm sorry. But the weird part is that when I go into OBS, there's no, like, it's not muted. Like, is there a disable or stop working mic button? A hotkey that says break everything? I don't know. It seems really weird. But anyways, so one of these are of opposite parity. Let's just label them as that, I guess. Just to remember that they're opposite parity. But they're opposite parity, so they have to be at least 4 apart. Oh, but they couldn't be, you couldn't have a 3 or a 7 in here because of what I just said. There has to be at least one low digit with 2 high digits, or 1 high digit with 2 low digits. So these can't be 3 or 7, so they are just like these two, 1, 2, 8, and 9. This will be probably the last puzzle in the stream because I need to make dinner as well. 1, 2, 8, and 9. These can't be 4, 6. I thought they could be 4, 6 before, but think about what happens to these cells if they're 4, 6. Then these cells are 2, 8. And if these cells are 2, 8, you can't fill this. 3, 7 will not work. So these cannot be 4, 6, which means that one of these is more impressive than 3 and 7. More impressive than 3 and 7. So that means there's either a 3 or a 7 in here. And that takes that last digit away from here. So on here, there's 3, 7, 2, 8. And now I know that there is 2 and 8 on here because there is one of 3 and 7 in here. Because both of these cannot be 3, 7. Because the only scenario in which that works is this is 4, 6, which means this is 1, 9, which we've already discussed is broken. So there is a 3 or 7 here because there is, if you look at the last 7 digits or the first 7 digits, there's only 3 and 7 on that string. So there is a 3 or a 7 in here, and there must only be 1. Because in here, we need to use 2, 3, 7, and 8. In fact, this cell is a 1 or 9. And this cell, wait a second. Have I broken this? No, I haven't broken this. No, I haven't broken this. One of these ends must be a 3, 7. What's the other end? Well, it can't go in any of these cells in the box. And 1 of 1 and 9 must not be on here because you can't have both 1 and 9 on a Renban, which is less than 9 cells. Think about it. If you had an 8-cell Renban, you could either have a 1 on it or a 9. You can't have both. So since 1 of 1 and 9 must be off the Renban, then one of them must be on the Renban. But there's no 1 and 9 in that 1 and 9 is not appearing in these cells, so it must appear on this line. So there's a 1 and 9, 1 or 9 on here, along with the 3, 7, along with the 4, 5, 6. So then these two cells are the other 3, 7 and a 2 or 8. And the other 3, 7, this digit right here, let me get rid of some coloring for a second. This digit right here must go right here because this digit cannot go on any of these cells, can't go there, and can't go here. So that digit is the same as that digit. And these cells must have a 4 or a 6 in them. And then a 3 or 7? Yeah. Must have 4, 6, and then either 3 or 7. So these cells must be 1, 2, 8, 9, because the 3 or 7 will have to have a 1, or will have to have a 2 or an 8 next to it. Because it can't have, this can't be 1, 9, because of the same reason we talked about before. This is 2, 8, and this has no fill. So one of these is 2, 8, which connects to the 3, 7, which has a 4, 6 on the other side, which has a 1, 9 over here. Oh, this has been... This has been, yeah, So for the muted thing, like, nothing is muted. Like, YouTube isn't outputting any sound, but OBS says that I have, so it's kind of weird. But that gives us a quadruple here, which means that these cells are the other ones. Where do these cells go in this row? Well, this one could go over here. Well, in fact, this digit, well, not this digit, but whatever 2, 8 is on here. If it's 2 on here, right? If it's 2 on here, well, we know this is going to be a 7. And then we know that the digit that is yeah, so then you can't put a 7 on here. That's the point. So then there will be a 3 on here, right? And a 3 cannot go with a 4 on here because these are opposite pairs. So if this is a 2, it will go with a 3, 6. And if it's a 8, it will go with a 4, 7. But this digit will be the opposite parity as this. Wait, doesn't that mean... Ugh. No. This will be the opposite parity as that. So then... Wait, in the case where the... Can this be... I don't think this can be a 4. I'm pretty sure this can't be a 4. I'm going to allege this cannot be a 4. Yeah, it might be the microphone itself. Maybe it's the connection or something. I don't know. I have no idea. I'm not sure. Maybe I'll try with a different microphone and see if it shuts off at some point. But I don't think this can be a 4 because that would need this to be a 9, this to be a 1, this to be a 7, but then... Wait, isn't that just fine? Isn't this is just fine, isn't it? Because the 8 is the opposite parity as 1. Okay, yeah. I've just proved that it's fine. What brand is the mic? Good question. Good question. Where's the brand on here? USB Professional, I guess? Yeah, it really does look fine. I'm not sure. It's just a cheap mic. I didn't want to buy like a really expensive mic, and there was one on sale, so I bought that one. It had good reviews, so, you know. Not sure. But, whatever 3, 7 is on here is also on here. And the 4, 6 is also on here. So we can ask questions like, where does this cell go in this box? It goes in one of those 2 cells. And the digit that goes with the 4 or 6 will also be in the box, because it will also be on the Ren band in the box. So if this was a 4 or 6, this would be a 1, 9, and this would be a 4, 6, 1, 9. Okay, I'm clearly not on the right trail here. So I need to reassess. Oh, I feel like I saw this about 10 minutes ago, but I didn't use it. There's a 2 and an 8 on here. So can the ends be 2 or 8? No, they cannot be 2 or 8 because there is a 2 or 8 on the line. Yes, very, very astute observations. Okay, so there's a 1, 9 here, which gives a 1, 9 pair, which means this is not a 1, 9, which means that this is not a 4, 6, which means this is a 4, 6, 1, 9. And remember 2 seconds ago, just 2 seconds ago, I said if this is a 4, 6, 1, 9, then these 2 cells are 4, 6, and 1, 9. So we can label those as 4, 6, and 1, 9. And that creates a 4, 6 pair in this column. This digit is also on the line and must be over here. So must be down here. I don't see how to use that. But, oh, there's still a 1, 9 pair in this column. So this is not a 1, 9. So this is the 1, 9. This is going to be, I almost say gray, but it's orange. So this is blue. So this is orange. So this is blue. Yeah. No, wait. The 2 or 8 on here is blue. That is a fact. But this is not necessarily the 2 or 8 on there. It could be, but it's not necessarily. There's always a 2. No, it's not true. It's a blue, or there's a, wait, this is blue now. So this is purple. Did I just say purple? What am I talking about? So this C's down here. Purple. Oh wait, the 1, 9 in here is orange. And that orange sees that cell. So this is orange, and this is blue, and this is a 2, 8, and this is a 1, 9. Very cool. Very cool. So if this is a 2, 8, 1, 9, so we'll need a 3 or 7, but I'm not confident I know which 3 or 7 it needs. This digit and this digit are down here. This digit is obviously down here. I can say that there's a orange 1, 9 up here. There's an orange 1, 9 down here. Oh, I can place the orange 1, 9 in this box. No orange 1, 9 there. No orange 1, 9 there. No orange 1, 9 here. And orange 1, 9 cannot be on the line. So this is an orange 1, 9. Which means orange 1, 9 is on this line, which means it is all orange, and it is 1, 2, 3, or 7, 8, 9. Because it sees a 4, 6, and because it has a 1 or 9 on it. Which means that this cannot be orange. Which means that this is blue and is a 2 or 8. Ah, beautiful. So this is a 3 or 7. And that is orange. Very nice, very nice. So this is not 3 or 7. 3 or 7. So this one is blue because it sees the orange one. So this one's orange. That's blue, 2 or 8. Nice, nice, nice. Orange 2 or 8 is up here. Over here we have the 3, 7, the 5, and the 4, 6. And those are all blue except for the 5, which is gonna call it gray. I'm gonna get rid of these pencil marks. So what are these digits? That one's not a 9. That's another reminder to to how do you feel about hints? Yeah, I should put somewhere on the screen that hints are good. Hints are okay. If I am struggling. Yeah, if it seems necessary, yeah. Oh, there's these 2 digits are in here, so those 2 digits are up here. So, so, please. Oh, wait a second. The last 4, 6 is down here. And it could be there. No, it can't be there. If this was a orange 4, 6, then both of these would be blue and they would be 1, 9. And that does not work. So this is a 4, 6 and it is orange because there are 3 oranges in the row. So this must be a blue 1, 9. This must be orange. This must be blue. We don't know exactly what these are. But this one, and this one, and this one, and these ones, and this one, mean that up here, these are all orange, and they are 2, 3, 4, or 7, 8, 6. Which means that these are either 5 or blue, and they're not 2 or 8, so they're 3, 4, 5, 6, or 7. This one is the other one, so 3, 4, 5, 3, 4, 6, or 5, I guess. This is the other one that's not up here. So that's all the blue digits. So these, or sorry, all the orange digits. So these are blue and gray. This one is a 1, 9 because obviously 1, 9 can't go in the line. So this is a 1, 9. So these are 3, 4, 6, 7, 5, similar to these. So this digit goes here, which goes up here. I don't know, we'll sort these out later. Maybe we have to do more. Yeah, in the description is probably a good idea. Maybe I'll add that quickly to the description. Just don't mind. Hints are acceptable, or are encouraged if I am being slow. Okay, so let's see here. We're definitely going to need to fill out this. And we can't use 1s or 9s. So we can't use 4s or 6s. So in here, there's going to be a blue 3, 7, and that's it. So either this is a 2, 8, 3, 7, which are both blue, or this is a 3, 7, which is blue. But if it's a 3, 7, which is blue, it will need a 1 or 9, which is orange, around it. So that is not the case, and in fact, it is 3, 7, 4, 6. Like, not 4, 6, not 4, 6, not 4, 6, 2, 8, 2, 8. Okay, so that works, which means that this is orange, and this is going to be 2, 8, because if it was 3, 7, then it would be next to 3, 7. That's not allowed. So this is not a 2, 8. There is definitely an orange 2, 8 up here, which does nothing. So I'm glad I didn't notice it before. The blue, wait, if there's an orange 2, 8 up here, then there's a blue 3, 7. Okay, so that's useful. That's at least a little bit useful. So I honestly don't even know how to notate that. This digit is up there. That's probably the best way to notate that. this can't have blue 19 on it. It can't. So it could have 4, 6, 3, 7, which are both orange, or it could have 5 with 4 or 6. But it definitely has a 4 or 6 on it somewhere. Oh, I got it. These 2 digits, where do they go in this box? Right here. These digits are this one and this one. Actually, I'm going to notate that too. So then these 2 digits are these 2 digits. So these are orange, and that made me look at this, which told me in my brain that this cannot be, like I said, orange 3, 4, 6, 7, because that would align here, and that would mean that we need to put both of these digits, which are up here and down here, into this cell. That's not going to work. The other way you can see that is that this digit is one of these 2. So if you rule it out of this cell not going to have an option. So that means that there is a 5 in here. So there's no 5 in those cells, so there's a 5 in here. Okay, that was actually not very helpful. It's a 5 down here. That's also not very helpful. This digit can't be 4, 6. Oh, could it be 4, 6? Oh, it might be able to be 4, 6 actually. So it might be 4, 6. It's not 2, 8, and it's not 1, 9. So this is either 2, 8 or 1, 9. It's not 9, so this is not 4 for sure. But I think it could be 6 with double 1. Don't see a problem with that yet. No, I don't see a problem with that. But we'll put a 1 here. There is a blue 1 or 9 in those 2 cells. I wish blue 2, 8 would see this. Blue 2, 8 is up here. Blue 2, 8 is in one of these 2 cells. Yeah, maybe I'll notate that. What is this, like maybe a red color? You suggest row 7, column 4. That seems very profitable. So this digit right here sees 5 in this box. It sees, I'll label it as not gray, black maybe. It sees 5. It sees 4 and 6 because they're both in here. It sees a blue 3, 7. It sees 1 and 9. It sees 2 and 8. So it must be 3, 7, and it must be orange. So this one is not 3 or 7, and it must be 6. That's very nice, Woofers. Thank you for that. I'm glad I didn't see that in a different way. Okay, so now we get a lot of things, because now red is 2, green is 3, purple is 8, this is 7, 8, 6, 9, 1, 3, 1, 6, 8. So these are 6 and 7. This is a 9. That's a 1. That's a 9. I'm probably doing this in the slowest way possible, by the way. These are not 6 or 7. These are not 6 or 7. These are not 6 or 7. These are not 3 or 4. So let's get rid of the red, the pink, and the green. These are not 3 or 7 because they have a 5 in them. We've already seen that. I got pretty far without getting that. This digit is almost known. That's 4 or 5. I think we've cleaned up all our pencil marks. Yes, that was very nice. 2, 9. I was looking to see if I could place that. Oh, I haven't cleaned up this pencil mark. That's a 1. So this is a 1 also. So this is a 1. So that's a 1. So we're just going to blue those 1s. That's also a 4 or 5. So over here we have, wait, I forgot to fill in this one. 8. So that's not an 8. That's not a 9. So there's definitely an 8 down here, which is not that interesting. So over here we have 2. We have an 8 and a 9. Same thing with this column. So this cannot be a 2 or a 9, so it's an 8, which means that this can't be a 9, so it has to be a 2. This can't be a 1, so it has to be a 3. This is a 9. Very nice. So that's a 7. That can't be a 7 or a 9, so that's an 8. And this is a 9. All of that was very nice. There is, I was going to say something that was wrong, so I'm not going to say it. That's not a 3. There's a 2 at the bottom here. Get those 2s colored, those 3s colored, the 8s colored, and the 9s colored. So no one yells at me for not coloring. Huh. There's definitely a 7 in here. So where does 7 go in this box? Has to go right there, which fixes the 8, which fixes this, which fixes... Oh, it doesn't fix this, but it's close. It's very close. That's a 3. So now we have 4 and 5, which means we can get this digit. That's a 7. That's a 6, that's a 7. We probably had by other methods, but I'm not sure what they were. That doesn't quite resolve anything. This is a 4, 5. This is 6, 4, and 7. Down here we have 6, 4, and 3, which is placed. This is 4, 5, and 6. That's not a 6. So there's a 4 or 5 in here, which means there's no 5 there. This can't be 2 or 9, so that is 4 or 5. So this digit is also 4 or 5. This digit's also 4 or 5, so that one's a 3, which we could have gotten by Sudoku, but, you know, long way around. The 3s are not going to give up, so we have to look elsewhere at this digit, which is a 6, which doesn't do anything. So we probably could have gotten it much easier way. This is a 9 because it sees a 2, so this is a 9, this is a 2, this is a 9. This digit is given, it's a, oh, we've broken the puzzle. Unless that can be a 2. What would this be then? It's a 6, I guess? So this is 5 and 6. That doesn't look broken to me. No, this seems fine. I think I just missed a 2 pencil mark here. Okay, I think you did say something about Mathpesto, but you retracted. It's okay, you can critique. Definitely missed that pencil mark. So that's a 4, that's a 3, that's a 4, that's a 3, that's a 5. 4, 5, 4, 5. This 3 gives us an 8 and a 3 and an 8 and a 6 to finish. That was very nice. I really like that one. I'm not sure how early you can get this one right here, but I think fairly early. Once I had this, the 4, 6 here. Oh no, I need the 2, 8 as well. Do you? You need the 2, 8? Thank you, woofers. I think I do need the 2, 8 here before you can get this. But I think you can resolve the parity fairly early. Maybe you need this before you can get this. I'm not sure. You do need the 2, 8 pair, yeah, you definitely do. But it was really nice. It was one of those puzzles where you obviously, some people would just put in one parity and then switch it at the end if it didn't work. But I almost felt like solving it without that. There wasn't that much that was like annoying without that. It was sort of I find like the most annoying part of those is when you have to color the smaller pairs, you know, like the 2, 8s and the 1, 9s. But I don't think it was really that important to do so. So yeah. Well, thanks for coming out and doing the stream and all that. And looks like 26 people viewed and stuff. So that's good. Not too bad. 4 hours. Oh my word. 4 hours, 3 puzzles, was it? Oh god, that's horrible. Okay. Well, thanks everyone for coming out. I think next time I plan on solving next time I think I'm gonna solve shards by Grockles. So tune in next time. I'm not sure when the next stream will be, but I'm gonna try to solve shards. So tune in for that. And yeah, I'll rate these puzzles and stuff. Yeah, thank you for helping a little bit with the mic. I'm not sure. It might be that setting that we turned on, the compressor. It might be there's some glitch with the setting because it wasn't doing that before. So I don't know. Anyways, have a good night.